Hi, this is Brian Schneider, a verification AE from Synopsys. Today I'm going to show you a short video of how you can isolate all the logic between 2 points in a gate level netlist. I'm going to show this example using a gate level netlist, but you can do the exact same sort of trace for RTL debug also. The first thing I'll start off with in this video is this idea for gate level debug is that you have to have, it's highly recommended to set up symbol libraries. And what symbol libraries provide for you is a way to see actual gate symbols in a gate level netlist. So we look at this schematic here, we notice how I see some flops here, I see an AND gate here, I see a complex gate here. If you happen to see boxes here for the symbols, this means you have not set up your symbol libraries. In this case, just reach out to your local Synopsys verification AE and they can help you get these set up. It's a fairly easy process. All you do is run a utility inside the Verdi package, which parses a Synopsys lib file or a Synopsys DB file and generates the symbol library which you read into the tool. So now, let's go back to the scenario I'm going to show here. In this example here, what I have is I know of two registers, a source register and a destination register, and I want to quickly be able to understand what is all the logic between those 2 points. If I was doing this manually or through other approaches, it would take some time to do this to understand what is all connected there, to understand what are the possible paths and how do I get from that source to destination. So the first part here I'll do is I'll go search for the starting point of this path, which I'll do from source, find signal instance. I'll turn on instance here, and then I'll put the name of the starting register, which is IDR reg. But also what I'll do is I'll select search full scope because I want to search the entire design and also include library cells. Especially for a gate level netlist, this is needed because all your gates will be normally embraced with tick libcell and tick nlibcell, so Verdi won't search those for default. So what I'll hit here is I'll hit find. I notice that I find 7 registers with this string, and what I care about is bit 7. So which I'll jump to the source code at this place here, which is this actual register in the source code. Next, I'll generate a schematic by tools, new schematic from source, driver. This generates a schematic where it's showing me what is the driving logic on the register of interest. The next point here I'll do is I'll go to the trace pull down and say trace 2 points, which brings up this dialog box. So I'll take this IDR reg bit 7, drag and drop into the from box. And we can see this auto fills all the possible pins. Now since this is my source register, I want to trace from the Q pin of this register. Next, I'll go back into the source code and I want to find the destination register, which is a register called IXR register. Again, I have search full scope and include library cell selected. I'll do find, and what I care about is bit 7 again, so which is this register. Now I'll just align my windows so I can drag and drop between those, where what I want to do is I want to take this register, drag and drop to the 2 box. So now I've filled in my trace 2 points dialog where I'm saying trace from the Q to the D, from the IDR register, the Q port to the D port. Then I hit trace. So what Verdi does for me here is that it goes out and says, here's my IDR register, my starting point. Here's my IXR register, the end point. And this is all the logic in between those 2 points. So it's a very handy trace to help me quickly isolate what is all the logic between there. And each one of these purple boxes you're looking at, these actually refer to levels of hierarchy. So I can zoom in here and see what level of hierarchy I'm looking at. So this confirms to me that this trace does cross multiple levels of hierarchy. And then I can use this for analysis to understand what's going on in this path, or if there's things that I need to debug deeper into, like is there a timing problem, a functional problem, so forth and so on. But the key thing here is by using the trace 2 points trace, I can quickly isolate all the logic between 2 points in the design, either for a gate level netlist or an RTL design. Hopefully you found this useful. Thanks a bunch for watching my video today. Have a great day.